Hey everybody! Okay, so I am going to do a little t-test review for you from the house. So a little extra challenging just because I don't have a big board to write on. So I've improvised a little bit and we'll just see how that goes. Of course, if you have any questions about this video, you can send me an email and we'll figure it out that way. Okay, so first thing, I do have a little baby board. Look at this cute board. Okay. So the first question I thought we would go over is just like, what t-test should you use? And I've already gotten some questions about this. I know we've talked about it a little bit in class and we've gone over it a little bit, but I thought I'd just put all three of them on this board and we would just sort of walk through it together. So the first one that we've talked about that we covered in class was the one sample t-test, okay? And I've tried to emphasize this over and over again, that if you have a population mean, so if the problem is talking about the population and whatever their average is, or sometimes they'll just say students in general or people in general or something like that, that's communicating an entire population of people. If you have a population mean, then you are going to be using a one sample t-test. If you are not given a population mean, then you are not using a one sample t-test. And it really is that simple. So the one sample t-test just compares one sample of scores, so one group of people in your sample against an entire population mean. So hopefully that one's going to be maybe the easiest to figure out, just because if you see them giving you a population mean, then you know it's a one sample t-test. The next one I have listed here is an independent samples t-test. Okay, so the independent t-test is basically when you have two different groups that you're comparing. So both of them are samples. So basically you're recruiting, say, 100 people and 50 of them are this and 50 of them are that. That's two groups of people, two samples that you're comparing, and you would use an independent t-test. While I'm here, I thought I'd also just make a quick plug for the fact that independent t-tests get used with between participants designs. So when you have participants in different groups, so let's say I'm randomly assigning 50 people, as we talked about in class, 50 people to receive chocolate for Valentine's Day and 50 people could receive flowers for Valentine's Day. If my people only get one or the other, then that's an independent t-test because they're only getting one of the options, okay? I could very easily turn that example into a dependent t-test if I wanted. So I'm going to bring up the dependent t-test options, lots of options here. So we'll go over those really quick. The first one that I have listed here is basically if you have anything where you're comparing people's before and after scores, then that's going to be a dependent t-test. Sometimes it'll be listed as pre-test and post-test, but same sort of thing. The other option, sorry, it's all backwards when I'm looking at it. So the other option is a group of people who go through two conditions. So this would be if I recruited 100 people and I gave them chocolate and looked to see how happy they were with that. And then I also gave them flowers and looked to see how happy they are with that. That would be a dependent t-test or within subjects design, as we've also talked about. And then the third option for a dependent t-test is if you have dyads or pairs that are connected in some way, where they're not independent of each other, then we would use a dependent t-test. So those are your three types of t-tests, three types that'll be assessed on the exam. So let's do a little practice with them for what kind of t-test you're going to use. So I have some examples here. Let's see how we go with this. Okay. All right, so this is like a typical fill-in-the-blank kind of section where you're indicating what kind of t-test you're going to use. Now, I want to highlight here that I'm asking about one sample versus independent t-test versus dependent t-test. Okay, that's what I mean by this question. So the first one is the happiness of students who get a snow day will be higher than the happiness of students in general. So the happiness of students who get a snow day versus the happiness of students in general. So you're trying to decide, is that one sample, is it independent, or is it dependent? So think about it. It is a one sample t-test. And the reason for that is going to be that it's comparing it against students in general. So that's a general population mean. So if you see something where it says in general or overall people in this group or whatever, that's communicating population. Okay. The next one is participants who take a service learning course. And it says that they will have a different level of community engagement than participants who don't. Okay, so both of these, this one's a little tricky. So you're looking at it, honestly, like when I look at this, I'd be like, okay, it's definitely, you've got two groups of people doing two different things. And so it's not dependent t-test. That's definitely not it. And then the key here is that it's independent t-test. And the reason for that is that you've got participants who are taking a service learning course versus participants who are not. And so you've got two different groups of participants that are doing something, like two different samples that are being compared here. So that one's independent. The next one is participants will report higher anxiety before the exam than after the exam. So participants will report higher anxiety before the exam than after the exam. This is a dependent t-test because it's a before and after scenario. So you're comparing before scores to after scores. That's dependent. So I'll write these all in a minute. Let's see. Students who participate in after-school activities will have more school spirit than the general population of students. So that's saying students who participate in after-school activities are going to have more school spirit than the general population of students. Now, here, hopefully, this one's the easiest one so far. Why? Because they say that population word, so you know that this is a one sample t-test, okay? Because you're comparing a group of people against a population. Roommates should report similar levels of dorm life satisfaction, okay? Roommates should report similar levels of dorm life satisfaction. This is really similar to the couples question that we talked about in class, so hopefully you're seeing that this is a dependent t-test, because the roommates are connected, so they're like a dyad. Participants are randomly assigned to either take a yoga class or a kickboxing class. We hypothesize that students in the yoga class will be more relaxed than students in the kickboxing class. Two groups of people doing two different things, and it's very clear here, I think, that there are two different samples of people that you've recruited that you're assigning to do two different things. So that is definitely an independent t-test. Okay, so I'm going to write these in and just show it to you again, just in case you missed any of them. So when we were talking about students in general, that was going to be a one sample t-test. When we're talking about the service learning course, we'll have a different level of community engagement than participants who don't. That was independent because we had two different groups of participants. Participants will report higher anxiety before the exam than after the exam. That was dependent because we have a before and after, so we have those connected scores there. Students who participate in after-school activities will have more school spirit than the general population of students. That was one sample because we have a general population we're comparing them against. Roommates should report similar levels of dorm life satisfaction. Dependent because our roommates are connected. Participants are randomly assigned to either take a yoga class or a kickboxing class. We hypothesize that students in the yoga class will be more relaxed than students in the kickboxing class. Hopefully we see that and know that that is independent. So two different groups of people. So I filled it in for us. So we've got one sample, independent, dependent, one sample, dependent, independent. Okay. All right, so hopefully that is clear. You definitely will have something like that on your exam, so make sure that you understand your 3 different types of t-tests. Okay. All right, let me find, I have so many different pieces of paper here. I think the next thing I want to do is to, while we're doing this, talk about between and within subjects designs. I do want you to be able to tell me what a between subjects design is and what a within subjects design is. Okay, so a between subjects design is when you have 2 different groups of people that you are comparing to each other. Maybe you're looking to see, maybe you think one's going to be better than another, higher than another, or whatnot. But that's between participants or between subjects design because you have people in 2 different groups. Okay, so they're not in more than one group. That is in contrast to within subjects designs, because within subjects designs mean that those particular individuals are going through multiple levels of the experiment or whatever it is that you're doing. So I was using this example a minute ago with the Valentine's Day and the candy versus the chocolate. You can easily make that between or within, right? So between would mean half your people get candy. Oh, it was not chocolate. It was chocolate and flowers. Sorry, chocolate and flowers. So between subjects design would mean half your people get chocolate and half of your people get flowers, right? So they only get one or the other. That's between subjects, okay? If we're talking about t-test, you've got some people here, some people here. You're comparing them against each other. That's an independent t-test, okay? So between subjects designs, go with independent t-test. The other one is within subjects design, so that would mean that all your participants could get chocolate, see how they like it. Then we'll also give them flowers, see how they like it, and basically compare those scores, okay? And if we're doing it within subjects design, we're going to use the dependent t-test, okay? So you will need to know that as well for the exam, as well as be able to provide an example of an independent and dependent t-test and something unique. I don't want you to just use the examples from class, okay? So come up with your own example of an independent t-test and your own example of what a dependent t-test might be used for. So many possibilities and options. So just do some thinking about that. And like I said, make it unique to you. So it's a design that we haven't seen before or talked about before. Okay. This is a little tricky, and so I definitely want to go over it. So I have a section where you have to find the cutoff scores based on certain information. And so you may vary in how comfortable you are with that T chart, okay? But this is sort of what that section would look like, all right? So it's basically saying, okay, find the cutoff score, the T critical score for the following different scenarios. So imagine you have a 1 sample t-test. You have an N of, 20, a p-value of 0.01, and it's one-tailed. Okay, so if you don't already have your T-chart out, you can pause me and go get it. Go get it out. Okay. All right, so remember there's 3 different things that we need to have for finding our cutoff scores. We need the p-value, which we have, 0.01. We need to know if it's one-tailed or two-tailed. It is one-tailed. And we need the degrees of freedom. Now, they don't give us the degrees of freedom here. They give us the N. And so in a 1 sample t-test, our degrees of freedom would be what? Okay, so our N is 20, so 20 minus 1 is 19. So I'm going to kind of just write that in really quick, that we have a degrees of freedom here of 19. Okay. So when you're looking at this, you're looking at the one-tailed section, 0.01, and it looks like the cutoff score for that, for a DF of 19, is going to be 2.54. 2.54. So I'm going to put that in there. All right, beautiful. So that would be my cutoff score. All right, next one. Independent t-test. My N is 37. My p-value is 0.05, and it is two-tailed. So remember, the three things we need here are whether or not it's one-tailed or two-tailed, which we've got, the p-value of 0.05, which we've got, and the degrees of freedom. But independent t-tests are tricky with their degrees of freedoms. We have three of them, right? You've got DF1, you've got DF2, you've got your DF total. The only one we actually need here is the total one, because that's what you need when you're finding the cutoff score. But this is where it's a little tricky, because you remember in an independent t-test, you have two different groups. They each give up a degree of freedom. So your DF total here is actually going to be 35. Okay, so your DF total here is 35 because in an independent t-test, you know you have two groups. We don't know how many people are in each group, but we know that each of those groups has to lose a degree of freedom. Okay, so our DF here is going to be 35. Okay, which I know can be a little tricky. So if you're having a hard time grasping that, definitely stick with me, but you can also email me and ask me questions. So a DF of 35, 0.05 two-tailed. All right, let's see here. 35. Okay, the cutoff is 2.03. All right. Next one. A dependent t-test, the N is 10, p-value is 0.05, and it's one-tailed. So which, like we said before, the only thing we're missing is degrees of freedom here. For a dependent t-test, we're only going to do our normal N minus 1. So our DF is going to be 9. Okay, so using the DF of 9, p-value 0.05, one-tailed, 1.833. 1.833. Okay. Last one. Independent t-test, an N of 16, a p-value of 0.01, and it's one-tailed. What is your DF total going to be here? Because remember, it's an independent t-test, so you need your DF total. It is going to be 14. Okay, so your DF total here is going to be 14. All right, remember we have two groups. They're each giving up a degree of freedom. We don't really, so I can imagine that there's 8 people in each group, and so the DF for each of them might be 7. 7 plus 7 is 14. But I'm probably just going to think of it as I know that I have two groups and they're each giving up a degree of freedom, so my DF here is essentially a large N minus 2. So however you want to think about it's fine, but just remember with the independent t-test, you have to, it's a little different. So your DF total actually ends up being 2 less than the total number of people. Okay, so for this one, DF of 14, p-value of 0.01, one-tailed, and I have 2.625. Okay. So those are your cutoff scores. Make sure that you found the same ones as me. All right, so I told you that, or at least I told one of the classes that I would do symbols again. Some of you guys might already have this, but if you don't, I wanted to put them on here. So we're going to go through each of these. So let's just kind of go through them first and see what you know. So capital M, that is your sample mean. mu, that is your population mean. The mu, the little m next to it, that is your population mean of the means. An S, that is the symbol for standard deviation. An SS, that is the symbol for sums of squares. Your S squared is your variance. S with the little m next to it. This one is classic symbol for standard error. Technically for us, it is the standard error for our one sample t-test and for our dependent samples t-test. So you could look at your formula sheet and you'll see there's an SM formula for both of those. Capital N, that is your sample size. Technically your total sample size of whatever it is you're talking about. DF is your degrees of freedom, which is typically n-1. Just remember with the independent samples t-test, you're doing n-1 for 2 groups, so that's why it's a little tricky there. Over here, whoa, hold on. Okay, DF total, that's only in your independent samples t-test, and that's when you take your 2 degrees of freedoms for your 2 groups and you add them together. Or as we were just doing up here, you're essentially taking your entire sample size and subtracting 2. So either way. Lowercase d, that is Cohen's d, or an effect size. The S with the little m1 minus m2 next to it is your standard error, but this is your standard error for your independent t-test. So the SM1 minus m2 is your standard error for your independent t-test. Capital D, that is a difference score that we calculate when we're doing dependent t-tests. The capital D with the bar on top of it is the mean of the D scores. And the P right there is like your p-value or your significance level. Basically the level at which you're comfortable with possibly rejecting the null and being wrong. So your type 1 error rate, if you will. Okay, so I will fill these in so that we have them. While I'm doing that though, I want for you to take a minute and write down what it means to have a type 1 error versus a type 2 error. Okay, if you can provide an example, that's even better because that's something you're probably gonna have to do on your exam. So you take a minute and do that while I'm filling all these in for you. And then we'll go over type 1 and type 2 error. Okay, so in case you're somebody who really is visual, I'm a very visual person, so it just helps me a lot when I can see stuff. So I wanted to make sure that I did that for you guys, so I showed you everything on paper, written out, even though we just talked about it. I thought that might be helpful. So if you end up with any questions about this, obviously you can email me. We'll chat about it. Okay. Type 1 versus type 2 error. So that's what you guys are working on. Remember, a type 1 error is when you have rejected the null. So basically you said that whatever you're doing in your study works, but in the real world it would not have worked. And we talked about this a little bit because we were saying it's not that you've done anything wrong, it's just that there's always a possibility that even though you've done this particular, let's say, intervention to try to get people to be better, it's possible they could have just been better anyway without the intervention. So there's always that possibility that you could reject the null and then it not really, the intervention not really work in the real world. So that is your type 1 error. And remember, your type 1 error is the same thing as your p-value. So if your p-value is set at 0.05, then it is a 5% chance of making a type 1 error. If your p-value is set at 0.01, then you have a 1% chance of making a type 1 error. Type 2 error is basically when you fail to reject the null. So you say that your intervention or your program does not work. There was no significant difference, but in the real world, it would have worked. And so this is a situation where something might have gone wrong. Maybe you didn't choose really good operational definitions for your variables that you were looking at. Lots of things could have happened, but essentially you found in your study that your hypothesis was not supported, but in the real world it would have been. So that's very unfortunate, but happens. Moving that p-value around will change the possibility of a type 1 versus a type 2 error. But remember that you can never push down your chance of both of them at the same time. So if you say, oh, I want a smaller chance of a type 1 error, that's fine, but that means that you're going to have a larger chance of a type 2 error. Okay, I mean, you're basically moving that line on your graph. So thought I'd just do like a little curve because we got to do our curves here. So okay, so here, let's say you have your 0.05 line versus your 0.01 line. If, so let's think about the 0.05 line first. So if I pass my cutoff here, right, so I reject the null, yay, and I say that my program worked, yay, I still know there's a 5% chance or less that I've made a type 1 error, but it's still possible. Let's say that I'm not comfortable with that 5%. I want to push it to 1%, right? So now I'd have to pass this cutoff here, right, in order to say that the intervention worked. But even though, so I'm making my possibility of a type 1 error smaller, but I'm actually adding in this additional section here for the type 2 error. So let's say my score falls right in the middle. If I've changed my p-value to 0.01, then I'm going to fail to reject the null. But it is possible that in the real world, my study would have worked and maybe the null should have been rejected. But I'd pushed my p-value down too small, so didn't happen. So just keep that in mind. They're always a back and forth. So if you're saying, okay, I want to reduce my chance of a type 1 error, you're increasing your chance of a type 2 error and vice versa. Okay, so you can never make them both really small. Okay, I think we have covered pretty much everything. if you have questions and you want to talk to me about anything in particular, please do that. You do have to complete basically the multiple choice and the short answer, all that part of your practice exam for Monday. So make sure that you are turning that in to me before your exam on Monday. I also need you to bring in your last problem set that we were supposed to turn in on Friday, the dependent samples t-test problem set. You're going to hand that in to me with your practice exam. So I'll look over both of them, make sure that you completed both of them while you're taking the exam. If I think of anything else that is pertinent that you guys need to know, I will definitely email you. But otherwise, reach out if you have questions or if you need guidance, and I will do what I can to help. Okay, bye.